Welcome back, everybody. Let's talk about the next kind of multiplication here, and this one deals with special products. Now, really, when we have two binomials multiplied by one another in this method, you can always go through and use your FOIL method to check. But in some cases, this is a real time saver, and let me show you why. We have the quantity right here. This is a rule that tells us if we have a binomial where we have the same terms as this other binomial, and the only difference is the sign. A minus b times a plus b always results in the difference of the two squares, a squared minus b squared. So let's think about what this actually means for us. If this is like the formula a plus b times a minus b, then when we multiply these two things together, we should get something that looks a little bit like that formula a squared minus b squared. Right? And students sometimes have trouble seeing this thing, but you should really kind of get the idea. Look, what's taking the place of A? Well, it's 10y. What's taking the place of B? Well, that's 3. What is the square of 10y? Well, the square of 10y is 10y times 10y. Well, 10y times 10y is 100y squared. So that should make some sense to you. Right? And of course, if I take 3 and I square it, I know I get 9. Well, if it is the case that we're taking 10y times 10y here, let me erase this to unclutter the picture a little bit. If I'm taking 10y plus 3 times 10y minus 3, what we've just been talking about should certainly occur. We should be able to get 10y plus 3, or a plus b, times a minus b, to give us a squared minus b squared. Well, a squared in this case is like saying 100y squared minus 3 squared, that's 9. So our result right here would be 100y squared minus 9. Now I've put some problems down here at the bottom again to try. Hopefully if you tried the ones from the previous video, you can pause and check those at your convenience. Let's take a look at these ones. There's two more formulas that we should know right here. The first one and the second one, they're basically the same. They are the square of a binomial. And it always turns out that if you square a binomial like a squared plus b squared and a minus b squared, we end up with a squared plus 2ab plus b squared. A minus b squared equals a squared minus 2ab plus b squared. Well, you're asking yourself, well, how is that? Don't I just distribute this square? No, you don't. People do, again, make this mistake all the time, and you need to be very careful in the way that you handle this situation. So let me show you why. If I say a plus b times a minus b, or sorry, a plus b squared, remember, a plus b squared is exactly the same as saying a plus b times itself. So this is like saying a plus b times a plus b. So if you carry out your FOIL method right here, right, a times a is a squared. A times b is plus ab. And then we do it again. B times a is ab, right? Doesn't matter which order we multiply those two in. B times b would be b squared. And so we end up with that formula, a squared plus ab is 2ab plus b squared. Okay, so in our formulas, whenever we're working these out, that's exactly what's going to happen. We don't really have to know too much other than what's A and what's B in each of these groups. So that's the way we're going to do this. Let's check it out. We've got 4x plus 3y quantity squared. Well, in this case, it looks an awful lot like we're saying, well, A is being replaced with 4x in the description. B is being replaced with 3y. So when I fill in the blanks from my formula, and it always helps me to write my formula along with the problem, a plus b squared always results in the square of the first number plus 2 times the product of the first and the second number plus the square of the second number. So let's see, what does that mean for me? Well, if a is 4x, then squaring 4x gives me 16x squared. If I multiply a times b, I get 12xy, but I'm multiplying that by 2. Well, that's 2 times 12, 24xy as my next term. For b squared, that's going to be 3y squared. Well, we know 3y squared is 9 times y squared, and this is our resulting expression based on the formula. It works in almost exactly the same fashion when we talk about a minus b squared. So let's talk about it. In this case, what takes the place of a? What takes the place of b? Well, it looks like a is being replaced with the quantity 5b. Don't let the letters fool you. It's still the same stuff. B is being replaced by 4. We don't worry about the subtraction sign in this case. It's just a minus b, so if it fits with the formula. The square of a we know is going to be 25b squared here, and the square of b is going to be 4 squared, which is 16. And if we take a times b, we know we're going to get 4 times 5b, which is to say 20 times b. So by our formula right here, if it's a minus b squared is a squared minus 2ab plus b squared, then filling in the formula is going to give us 25b squared as the first term. We're going to take ab, which is 20b, and multiply that by 2, so it's minus 40b plus b squared. Well, instead of b, it's 16, so plus 16. And this is our simplified expression. A few more examples like this at the bottom. Please take a moment to pause and try your work on this.